All right, so yeah, SPDM 1.3 and beyond. For those who don't know me, I'm Brett Henning. I work for Broadcom as a security architect. I was actually the security architect on the storage controllers that were used in the demo for the last presentation. But today, I'm here in my capacity as one of the co-chairs of the SPDM working group in DMTF. And I'm here to present SPDM 1.3 and then some of the stuff that's coming after that. Just standard disclaimer here, the stuff that I'm presenting from 1.3, that is a published spec. That's going to stay the same, but the other stuff that's forward-looking, that's still under development. It might change a little, it might change a lot. So, it's a preview, but that's all it is. So first, we've got some of our alliance partners. The alliance partners are an important part of what makes SPDM work. We have a lot of buy-in from a lot of groups in the industry, including OCP. We've had a partnership with OCP going back to essentially the start of SPDM and the start of the OCP security project. Right? They kind of grew up together and have been very important to each other. Just kind of a quick overview, what is SPDM trying to address? This is a picture we've had around for a while, but it is still relevant. We're trying to address security threats within a platform. Right? What we're showing here is just a chassis, but this, as we'll see, this has been extending out to a broader definition of a platform over time. But the threats that we're addressing are still largely the same. It's things like malicious firmware, compromised firmware of some sort, compromised devices trying to impersonate something else, attacks on the management buses, and all that sort of stuff. Okay, so SPDM 1.3, there's a number of new feature categories that went into 1.3. This came out about 6 months ago, so that's about the timeline that we're looking at here. But we've got about half a dozen major feature areas. As a general note, all of these features are optional. So you're not required to support them, but for devices that need these new capabilities, you can add them. So first up, we've got event notification. At its core, this is really just an asynchronous event notification mechanism like everyone's used to. There's a subscription model, so you can reach out to a device and subscribe to the events that it's throwing off, and then those events will be sent over a secure channel. The design of the event notification mechanism really was meant to make it a reliable transport, so there are acts on the events, so you actually know they got there. But why did we do this? Well, we put in a handful of events that were DMTF defined. Those are firmware notification, or firmware change notifications, certificate change notification, things like that. This mechanism can also be extended. So vendors can define new events. Organizations like OCP can define new events. Right? It's really an extensible mechanism. But you might ask, right, with things like measurement changes, firmware changes, right? We all have event mechanisms for that, right? The controllers I work on have event notification mechanisms, but those all happen in a different framework, right? They might be heading to the firmware update, driver. They might be heading to the management plane. We really wanted something that was in the security plane. And so SPDM seemed like the right place to put this because it really is using that secure channel between the device and the PA rot. And just notifying it that, yeah, your view of me might have changed due to an event. You need to come rerun your attestation. Next up, multi-key. So this one was a lot of work to get into the spec. There were a lot of changes that were part of this. What really changed is going all the way back to SPDM 1.0. We've had this assumption in SPDM that there's only one key or one key pair for the device. And yeah, there were 8 certificate slots, right? That also goes all the way back to the beginning. But there was always just one key. So all of your end entity certs or your leaf certs, right? All 8 of them had to have the same public key in that end cert. Well, we've added multi-key support because we've had a lot of requests to move beyond that. Use cases for this, a big use case is just separating the uses of the keys. So you might have a key that you use for challenge and a key that you use for get measurements, right? In the OCP attestation spec, this is a dev IK and a dev AK. So now you can actually create these multiple keys and assign them to different uses. Backing up this mechanism, there's a lot of key management as well, right? Because as soon as you add multiple keys, you have all these natural questions of, well, how do you get them? How do you count them? How do you delete them? So there's a whole key management mechanism behind this, which is why there was a lot of work driving into the spec, and that's why it took us this long. The other big thing that's in there is you can actually tell the device what use cases you want the key assigned to. So you might say, I want a key that's only going to be used for challenge. And in that case, you can tell the device, and if the device receives a request to assign some measurements with that key, it's going to reject it. As part of that change, we actually added what we're calling a new certificate model. So this is just called the generic certificate model. I know that's can't help it, but it is a generic name. Over time, this is the 3rd certificate model that SPDM has added. So going back to 1.0, there was always the device certificate model where the leaf cert just represented the hardware identity. In SPDM 1.2, we added support for what we call the alias certificate model. This is something that looks a lot like a dice cert chain. With multi-key, we really wanted the ability to just add basically any X509 compliant certificate chain, that just follow the RFC rules. So that's really all that a generic cert chain is it's one that follows X509 rules. It doesn't have to follow the device cert or alias certificate rules. The one catch with this is you're not allowed to put it in slot 0, so device identity is still one of these, either a device certificate or alias certificate chain, so you still have to put device identity in slot 0, but 1 through 7, you just have a lot more flexibility. New measurements. So this is a small flag, but it does unlock a new capability. And you'll see this one goes along with some of the other stuff that was in the event notification, and that's on purpose. Let me just walk you through the case a little bit. So with SPDM, you might come in and do a get measurements request. And let's say you're just going to say, I want measurement index 5, and that's my runtime firmware measurement. Well, that's great. You can check the measurement. That's something that's been in the spec this whole time. So you can check the measurement. You can compare it against what you know about the runtime firmware. But what if you have a pending firmware update? Where do you go for that measurement? What you've typically done is that might be index 50, right? You have to look in the vendor documentation. They tell you, oh, it's over here. Or they might tell you, oh, we forgot to add that. Right? There's all kinds of choices, but it's really very vendor specific. Now there's this new measurements flag. So now you just flip this bit and send the same request to index 5, and it'll tell you, here's the measurement of what is pending for my runtime firmware. And then you can take that, you can compare it against the co-rim for the incoming firmware image, and you can figure out whether or not this is compliant with your policy. Okay, measurement extension log and hash extended measurements. Essentially, this mechanism boils down to this is like a PCR extend operation. So if you're familiar with that, this will look very familiar. This is a new mechanism that is built into the spec to represent a hash and then a log of actions that are taken on a device. This might be actions taken during boot. This might be layers loaded during boot. It could be configurations applied to the device, right? All sorts of things can go into this log. And as the log is processed or as the underlying elements are processed, the log entries will go into a hash that just keeps getting extended. And then you can retrieve that hash and you can retrieve the log. Now, SPDM isn't going to tell you how to protect the underlying elements. There are standards bodies that'll do that, right? TCG tells you a lot about how to protect those underlying elements. What SPDM is doing is it's enabling the reporting of that. So it's added structures that allow you to go get the log, they allow you to go get the measurements, and they allow you to make sense of all of it. Okay, structured manifest. So SPDM's had the concept of a manifest for several iterations of the spec now. I think it went in 1.1. We just added a measurement type that said, what I've given you in this report is a manifest or a measurement manifest. And that's about all SPDM told you. The problem is you have no idea what the structure of the data that you got back is, right? You got a blob of data. You have no idea how to process it. So you end up needing special knowledge that basically comes from vendor documents that tell you, here's how to process my measurement manifest. Well, 1.3 added what we're calling a structured manifest. And this is just, we had to assign a new type number to it. But basically, we just take that manifest and we put a header on top of it. And this header tells you who defined the manifest format. It's that simple, but it's a big change. And the reason it's a big change is this was actually done in cooperation with TCG. This was leveraged in the TCG evidence to SPDM binding spec. So we work cooperatively as alliance partners and basically rolled the change out together. So now you can use this to transport, say, a co-rem. And you can get an identifier that will tell you what you're looking at is a co-rem. And so now you know how to process, or I guess it's really the concise evidence, but you're getting concise evidence and now you know how to process that. Last of the new features is endpoint info. So this is really just kind of it's a little bit more generic command, but this just lets you get information out of the device about the device, right? It's telling you about itself. The primary use case for this really is you can get device identifier information. So, vendor and device ID, for instance. And that'll let you look up cached information about the device. So now you can go say, yes, I've seen the device before. Here's the information I know about it. Here's my policy that I have applied to it. And then you can shortcut a lot of the bring up and basically jump straight into a challenge and just get off and running with the device. Again, optional, but it is there as a nice shortcut to bring up systems faster. Okay, so that's our existing. That's all the SPDM 1.3 spec. And that is, as I said, that's available today. And it's really meant as just a growth of the SPDM feature set that we've had so far. So what's coming? We've actually got 3 topics that we're previewing today. 2 of these are public. 1 is not actually public. We're making it public as of today. So first, we have the SPDM over TCP binding. So this is an effort to really take just the standard SPDM spec, right, our document number 274, and lay that on TCP. Well, why would we do that? The use case really is RDMA. So this is meant for really rack level platforms. And they needed a method to attest devices to figure out if they were trustworthy before they started opening up RDMA memory windows. So that was a pretty important use case. So we are working to enable that. There's a couple mechanisms. If you see here in the flow charts, there's a couple ways of discovering. You can basically come from, essentially top down, or devices can notify when they get added and say, hey, I'm here. And so either end can start the transaction. After that, they look the same. And you'll notice that inside what they're doing is they're just running SPDM. So this is unmodified SPDM. It's just wrapped up so it can travel across TCP. Other use cases, you can do rack level attestation. So you can take attestation and maybe you move it off the BMC and move it to a rack level manager. You can do provisioning of certs, right? You'll have a CA in your data center and you can push certs down. Well, being on the network gives you a lot of advantages in doing that. So that's spec 1 that is coming. That is currently in development. Spec 2 that's coming, taking the same thing and applying it to storage. So this is a request that we've had for a long time. I know going back to early drafts of the OCP attestation spec, we had documentation there saying that someday this needs to be extended to storage devices. Well, that's happening. DMTF is working on taking, again, SPDM, unmodified as it is, and putting it onto storage buses. This is really targeting SAS, SATA, and NVMe over fabrics. You will notice I left out NVMe over PCIe, and that's really just because PCIe already has DOE, it has mailboxes, it has VDMs, right? It has a dozen different ways of sending SPDM commands. These other transports really didn't have anything. So we're working with, again, working with partner organizations. We're working with the organizations that manage these transports to define a way to get SPDM onto these transports. So we are leveraging existing commands. So we're using the security protocol in and out commands for those of you that are familiar with storage. And we're just really defining how do you take that security protocol command, put SPDM inside of it, and send it across the bus. And then obviously rules that go along with that. Again, use cases, I mean, this is pretty simple, right? You might have a server with 20 devices inside the chassis and then 500 drives hanging off the back end, right? Right now, those 500 drives are not attested. So there's a big need to move authentication out to those devices. And then another use case that we're working on is establishing a secure session. Well, why is that important? Well, you have a lot of secure drives, right? Self-encrypting drives. They need a key. Today, those keys are actually all sent in the clear. It's the way the buses work. We want to take the secure session that SPDM has and use that to transport the keys. So now keys are no longer traveling in the clear. So this is a major improvement to the storage ecosystem. So that's spec 2, that's also in development. Spec 3. This one's also in development. We are very busy right now, and none of it is on SPDM, on the core SPDM. It's a lot of this peripheral stuff. So number 3 is an authorization spec. This is something that we've not been discussing publicly yet, but we're ready to discuss it publicly. So we're creating a new specification that is specifically built around device authorization. So think of this as a privilege management spec. So this will provide a way to discover privileges that you have and to manage those privileges. So think about a firmware update case. You might say you might have a user who has privileges to update firmware, and then another user who doesn't. So if the second user sends a firmware update command, this spec would enable the device to say, no, you don't have the privileges to send that. I'm rejecting the command. This is, again, something that is being built on top of SPDM mechanisms. So we're leveraging SPDM secure messages and some of the other capabilities in SPDM to build out this spec. The idea of the spec is this can actually be used for pretty much any command. So we're going to use it for SPDM. We're also going to enable vendor-defined commands and PLDM and RDE. Right? Whatever you need to pull into this authorization framework, you'll be able to. One key aspect of this is we do have a requirement in there that this has to be data center ready. Right? This has to be scalable. Right? We know that users are going to need to manage thousands, if not millions, of endpoint devices under this framework. So this is something that has to be built with scale in mind. And that's it, the call to action. So, we know that SPDM is an important part of the ecosystem. We understand that, we respect that. We're trying to maintain SPDM, and we're trying to maintain its core while extending it as needed. We're definitely still working with additional organizations. So we do have a statement up here that we're working with ISO on ratification of the SPDM spec. We know that some organizations require that before they can use a spec. We're honoring that, and we're trying to help them. And then beyond that, we're continuing to work with organizations. Anyone who's a member company is welcome to come to the meetings. You can go to DMTF, sign up, start coming to the calls. We have standards on here. We have an SPDM forum. There actually is just an open public forum where you can go ask questions. Those questions are actually addressed by members of the work group, so you tend to get pretty high quality answers out of there. And then we have a feedback portal. So any requests that are coming in, say from OCP, we do have a portal where we can take in those requests and do all the appropriate IP scrubs that we need to do. But then we can take in these public feedback requests. So with that, that's it. Any questions? I do know we've got about half of the SPDM spec authors in the audience, so hopefully we can get anything answered.
Yeah, I have a quick question. Do you see NOR Flash adopting SPDM? Just standard NOR Flash. Do you see any of it?
We haven't seen that yet. We did have JEDEC on there as a partner org, but that's more DRAM focused.
Right.
Yeah, nothing yet. I think it'd be feasible though that you can do it pretty lightweight. So,
right.
Yeah, certainly any vendors can reach out.
Yeah. So if your answer was yes, I was wondering if there was going to be any abbreviated version of SPDM for smaller peripherals, or less capable peripherals in terms of user interface and command control.
Yeah, nothing planned yet. Okay. That's something we'd be open to if you have, especially if you have ideas or concrete things that you want to see in there. Definitely, you can send them through the feedback portal. I think we're open to the idea.
Okay. And then the last question, TCP. Do you see, with the advent of all these open specs, how do you see TCP changing or adapting and fitting into the landscape moving forward? I mean, maybe it's a personal opinion.
Yeah, I mean, I think the use of SPDM over TCP, that's really focused on...
Oh, I'm sorry, a trusted computing platform.
Oh.
Yeah.
Okay. Yeah, so I guess I don't have a strong opinion on that, so
okay.
I'll leave it there.
No, understood. Thank you.
Hi, thank you for all this. Question on the measurement log stuff. I noticed you said
Yeah.
that the responder can report both the hash and the log itself. I'm curious, is that generally expected that devices will be reporting the log, or is that kind of just an optional feature that most people probably won't do? Or is it up in the air?
I think it is up to the device vendor. I think some will report the log. Obviously, you would want some kind of protection on the reporting of the measurement, or on reporting of the accumulated hash, right? Yeah, otherwise, nothing's trustworthy. Yeah.
So, question on the TCP binding of SPDM.
Yeah.
In that environment, the meddler-in-the-middle attack described earlier is highly relevant. Of this attack, the attacker compromises a device, replays old good attestation, and then allows the challenge to go through the device so that you get a fresh answer to the challenge. For SPDM over TCP, what needs to be done on the host side to block that attack?
Really, the important part is make sure you have all your transcript tracking correct, because both sides will track a transcript hash. And so if the endpoint never sees all those requests that keep getting intercepted in the middle, its transcript hash will be off. And so that's really the defense against that. Yep.
I have a multi-part question about SPDM version compatibility. I keep
Yeah.
hearing about incompatibilities between SPDM 1.1 and 1.2, and I'm wondering, are those real? And if so, is that a one-time incompatibility, or is incompatibility like a feature of every SPDM version? And how does it work when you have every device in the system with supporting a different version of SPDM?
Yeah, so that is real. That there are extensions to the spec, basically each rev. So there can at least be new fields coming in and new capabilities coming into existing fields. We do try to keep the bit definitions the same, so we try to make it a pretty light lift to support multiple versions. So let's say you support 1.3, we try to keep it pretty lightweight to just add in 1.2. But yes, there are a handful of behavioral differences. And so that's part of the reason that SPDM does require an exact version negotiation, right? It's not just 1.3, 1.1, and you kind of agree and everyone runs on. You do need to both match on, say, 1.1.
So the way it's handled in a system where every device supports a different SPDM version is you just downgrade to the lowest common denominator, and therefore all the devices that support newer versions of SPDM need to support old versions also?
Well, it's typically a one-to-one, so it'd be between the BMC and each device. So the BMC is allowed to negotiate to different revs for each device, if its policy allows it to. So that'd basically be the handling route.
Appreciate that. And then highly appreciate all your effort around the year working on the specs. I do attend your SPDM calls, pretty comprehensive. That thing, and then want to understand that suppose we have a use case where the device does not support secure sessions, and we want to write the certificates both in slot 0 and slots 1 to 7. So that is allowed only in a secure manufacturing environment. Suppose the device vendor writes the slot 0 certificate in their manufacturing environment and ships the device to a customer where they want to write slot 1 to 7 certificate. But how do we ensure that during the transport that device doesn't get hijacked and somebody else writes it? So does the spec want to get into that? Because didn't see some guidance on that.
Yeah, and that is something SPDM definitely shies away from policy recommendations. Really, it's mechanisms. So you would need to build a mechanism using the spec. What you would probably do is just go out and query the devices. One thing that wasn't mentioned was SPDM 1.3 actually has commands to go and erase all the slots. So you can take, except for slot 0. So you can take 1 through 7 and you can just go issue erase commands to them and tell the device to start over. So that would be a way to just kind of purge it.
Okay. And another part was that suppose we speak about the RIMs, the reference integrity manifest, the mechanism to revoke the RIMs in the field, we would look towards the TCG spec
Yes.
for that?
Yes, absolutely.
Sorry, we're actually over time.
Yeah.